gentlemen, boys and girls, it's Mr. Zabo. Today we are going to be covering sections 1.2 and 1.3. Most of it on this video, a little bit live in person after you guys watch this. So, let's start with congruence. Congruence is determined or is talked about with a lot of things. Specifically today we're going to focus on segments and angles. Congruent segments have the exact same length. Congruent angles have the exact same measure. You can see the symbol that we use for congruence is the equal sign with that squiggle above. Now, it is important how we mark things. In our diagram, if I want to state that segment AB is congruent to segment DE, on my diagram, I'd have to mark it with tick marks that are the same. Okay, one tick mark I did here. Can be anything. Okay. Segment BC congruent to segment EF, I have two tick marks. That has to be consistent. These statements are slightly different than this statement. And you can see that a couple of the differences are no segment bar here. That means I'm actually talking about the physical length of that segment, the measure of the segment, you can say, and that's equal to the length of this segment. So I would read this statement, segment AB is congruent to segment DE. I would read this segment as the length of the segment AB is equal to the length of segment DE. So it's slightly different writing and slightly different than interpretation of what I'm saying. They're really saying the same thing, but there's a small difference. Okay? Same thing with angles. If my angles have the exact same measure, I can say that angle A is congruent to angle B. Keep it at that. But if I want to use an equal sign, I have to state that the measure of angle A is equal to the measure of angle B. Okay? Small differences that make a big difference in the end. Now, if we get a little bit of practice with this, okay. First, we have the statement that segment WX is congruent to segment YZ. I can make the conclusion if this is true, then the length of WX is equal to the length of YZ. And now I can go ahead and supplement or substitute what I know. I know that WX is 16A minus 5. I know that YZ is 13A minus 7. And then through the magic of video and algebra, I am able to identify that A is negative 2/3 and WX is negative 15 2/3. But wait a minute. How can a segment have a negative side length? Did I make a mistake? No, I didn't. Well, that's an interesting situation. What this means, as I go back and check all of my algebra, is I have an extraneous solution. And what we would state here is technically that, yeah, A is negative 2/3. They asked us to find that, but it doesn't really work. So I would state that there is no solution to this. That's extraneous, we call that. And then in example 2, again, I have angle A is congruent to angle B. If I want to find X, I have to then take the logic step that the measure of angle A is equal to the measure of angle B, and now I can state that x squared minus 6x is equal to 16. Oh no, I have to solve a quadratic! Yeah, you're going to solve a lot of quadratics, and we'll talk a little bit more about that in class, but you're going to solve a lot of different types of algebra problems that you're going to have to make sure you know how to do. Luckily, we're in a video, so we have some magic. Through the magic of video, this quadratic was solved using the factoring method and the zero product property. And I got two answers. I got 8 and negative 2. You have to make sure you're always double checking that. Substitute back in. So I took my 8, I substituted back into the measure of angle A, calculated, I got 16, which is what's supposed to get, because that's the measure of angle B. Okay, and so that worked, and then I did the same thing with negative 2, and it got 16. That also worked. There are two solutions to this problem. Some things about angle measures. We're going to do a handful of things about angle measures today. This is the first one. So we know acute angles have to be less than 90, but don't forget, they also have to be greater than 0. And we know right angles have to be exactly 90, and straight angles exactly 180, obtuse angles less than 180, but don't forget they also have to be greater than 90. Okay? It's important when we get example problems like number 3. When I say that the measure of an angle is or of an obtuse angle is 6y plus 42. What are the restrictions on y? Well, first, I have to conclude that it's an obtuse angle, so the restrictions on the angle are greater than 90, less than 180. So I write my restrictions on my angle measure. Okay? Greater than 90, less than 180 degrees. That is the restrictions on my obtuse angle. Now I substitute in what I know about my angle. I know it is 6y plus 42. I have a compound inequality. I need to solve this compound inequality algebraically to get the restrictions on y. So again, my restrictions on y are that the variable has to be greater than 8 and less than 23. A difference between restrictions on your angle and restrictions on your variable. Next topic today, collinear, non-collinear, and betweenness. Okay. If points lie on the same line, they are considered collinear points, whether they're 2 points, 3 points, 5 points, a billion points. If points do not lie on the same line, they are non-collinear, but it has to be 3 or more points. We talked about the other day, if you have 2 points, they are always collinear. So in our diagrams down here, D and E are collinear. Even though you don't see a line drawn, there is a line. So it's 3 or more points can be non-collinear. It's important when you come to the term betweenness. If we ever state that a point is between 2 other points, we are stating that they are collinear. You cannot be between 2 points unless you are collinear. So in our diagram on the left, B is collinear with A and C, so it is between A and C. But E is not between D and F because they are non-collinear points. So those 3 terms are all very kind of linked together. You have to make sure you're aware of them. Moving into a concept of non-collinear, and we'll get to it, and as I scroll down in a second, you can see collinear points, 3 collinear points, they can form a line, a segment, a ray, but they can't form anything really else. 3 non-collinear points can form a triangle. And that's where we get the triangle inequality theorem here. So the triangle inequality theorem states that the sum of the lengths of any 2 sides of a triangle is always greater than the length of that third side, or in this case, if I add the length of x and y, it has to be bigger than z. If I add the length of y and z, it has to be bigger than x, and so forth. And let me give you a diagram here that might help illustrate this. Okay. Here, A, B, and C, there's no way I can form a triangle here. And there's no way, there we go. And I'm not even able, I can't move B to get a triangle formed. They won't connect because A and B don't add up to C, or more than C. If they added up exactly to C, we'd be collinear. If they added up to more than C, I could start to form a triangle. Less than C, they don't connect. And so that's just a quick kind of diagram of what we're talking about with the triangle inequality theorem. The topic we want to talk about in this video is making conclusions from diagrams, and specifically talking about what can we conclude and what can we not. This is a list that will evolve as we go through the semester, but for now we want to focus on this. We can always conclude straight lines and angles. So if it looks like it's a line, we can conclude that it's a line. We can conclude it's a straight angle. We can conclude it's 180 degrees. We can conclude by looking that 3 points are collinear if we see a line through them. We can then conclude that we have betweenness. If we can see that line and we see the 3 points are collinear, we can conclude betweenness. We can conclude relative location of points. I can conclude that in some of these diagrams up here, A is to the left of B. I can't conclude any detail specific, but relatively A is to the left of B. So kind of general concept, general ideas we can draw a conclusion on. Okay. We cannot conclude right angles. I cannot look down here at this diagram below, for example, and say angle 4 is a right angle. We can't make that judgment. We have to be told specifically in order to make that conclusion. We can't look at the diagram and conclude that. We cannot conclude congruence. I cannot look at a diagram and say, oh, those segments are congruent. Just because they look like they are. I have to be told specifically in a number of different ways that they are. Now, really only in one way, but there are a few ways that we can be told that. And we cannot conclude relative size. This is one that really kind of messes with our minds a little bit. I cannot conclude that an angle is obtuse because it looks obtuse. I cannot conclude that it's acute because it looks acute. I have to be told specifically that it is. I cannot conclude this segment is longer than that segment, even though it might very obviously look like it on paper. Okay? Diagrams will not be drawn to scale. Nothing will be drawn to scale. We have to be able to look at what we've been told. Okay? So with that said, I want you to kind of create a quick list, press pause on the video and create a quick list on what are the things that you can conclude on this diagram. Write as many as you can think of, and I'm going to write a list after you pause and try it. It consists of only 3 things. Hey, I can conclude angle 1 is congruent to angle 2 because the diagram tells me, not because I can conclude by looking at congruence, but these marks are one way of being told that they are congruent. And then I can conclude that angle 1 plus angle 3 plus angle 4 is 180 degrees because I can't assume straight lines or angles. And the same thing for angles 2 and 5. All right, so now I'm going to give you a new diagram. And can you make these conclusions? So can you conclude that segment DB is congruent to segment BE? If so, why? So for example, I'm looking here. Can I conclude that segment DB is congruent to segment BE? Yeah, of course I can. I have those tick marks telling me that I can. Okay? So see if you can come up with a conclusion for the rest of this. For B, C, and D, you cannot draw that conclusion. There's not enough information to make those conclusions. E and F, you can. Okay? For F, we can conclude or we can assume straight angles. And because we can assume straight angles, we can also assume vertical angles. So if you don't remember what vertical angles are 2 angles that are formed by intersecting lines. Because we can assume lines, we can assume vertical angles. So angle ABE, this angle here, and angle DBC here are considered vertical angles. Okay? So we're going to stop for there. And we are going to come back to class at this point and go over a few more things with angles.